Linear. Okay, our favorite. Y equals mx plus b. Domain. What are we feeling? If we start at the left, do we have points at negative infinity?
Yeah.
Do we have points all the way through to positive infinity?
Yeah.
Yep. So domain is all real numbers, negative infinity to infinity. What about range? Same thing. Down here we have points. To the top we have points. And that's the same for every linear function. It's always negative infinity to infinity. Next one. Anyone remember how to classify this? Go ahead. Quadratic, because of that 2 in the exponent. So this is a quadratic. If we look at domain, starting at the far left, negative infinity. Do I have points over here?
Yeah.
How do we know? The arrow, perfect. Going all the way through to positive infinity. Do I have points over here?
Yeah.
Yes. So my domain is negative infinity to positive infinity. My range, do I have points down here at negative infinity? No. They start at negative 9. Is negative 9 included?
Yeah.
So we use brackets. Do I have points all the way through to positive infinity?
Yeah.
Perfect. So infinity, parentheses. Again, anytime you have an arrow, you're going to be dealing with infinities. Same thing goes for today. Okay. Second one on the warm-up is solving an equation. We got to make sure we have this down because we have to know how to solve equations to know how to solve inequalities. So, if I wanted to solve this for x, what's the first step on the left? Seamus. What?
Do them parentheses.
Yeah, distribute. So I'm going to bring that 5 into both pieces. 5 times x is 5x. Negative 8 times 5 is negative 40. Right side stays the same. Now what?
Minus 40. Plus 40.
Sure, we can add 40. If I add 40, what do I want to do with the 9x? Subtract 9x. 5x minus 9x. Negative 4x. 20 plus 40 is 60. Last step.
Divide by 4.
Divide by negative 4, we get x is equal to?
Minus
50.
50.
Yeah, negative 15. How do I know that that is true? How could I? Yeah.
You could multiply it by 4. By minus 4.
We could check our work backwards that way, but how do I know that this is my answer?
Plug it in.
Yeah, we plug it in, make sure that it's a true equality. We're going to talk about that today too, plugging stuff in and checking. How do we feel on a up, sideways, down on solving equations? I hope we're all up here. If we're not up here, come to my ACT lab on Wednesday. We got to be up here.
I
Okay.
have a question.
Yeah.
So I don't know what happened to my thing, but like after I did that, I subtracted by 5.
That's fine.
Okay, 5x,
Mhm.
and then it was 4x plus 20. Subtract 20 on.
Mm-hmm. So you should
okay,
get
I just saw
negative
I
60.
added 20 on.
Yep, there you go. Any other questions on the warm-up? Okay. Inequalities, again, mostly review, so just bear with me. We have 2 types. First one is called a simple inequality. That's the stuff that you're used to. X is greater than a number, or X is less than a number, or greater than or equal to, or less than or equal to. We have one inequality symbol, one variable. That's the stuff we've seen before. The other type is a compound inequality, when we have more than one inequality symbol, but still only one variable. And that's when we use our words and or. So, if we remember for or, we talked about it a little bit, but math or, if we drew a Venn diagram, goodness, what parts of this diagram would be shaded in if I'm talking about or, this or that? Go ahead.
Middle.
The middle at least. What else? This or that. Doesn't have to be both.
No.
All of the left side, because that works, and all of the right side. It's this piece, or it's this piece, or it's both, but doesn't have to be both. When we write those as an inequality, we keep them separate. So if we use the word or, we really do write the word or. And typically for or inequalities, you're going to have two different symbols. Might not always happen, but typically your symbols are going to be opposite directions. This one can be true, or this one can be true, or they can both be true. Okay? For and, it's a little bit different. What piece of this diagram would we shade in for and? Just the middle. Okay. For and, both pieces has to be true. This inequality has to be true, and this inequality. And for that reason, we don't write two separate inequalities. We combine them into one, where we have two symbols with one inequality, or with one variable. A number is less than x, which is less than a number. We are taking this inequality and this inequality, and we're shoving them together because both have to be true. Okay, so if you see and, I want you to think of sandwich. Your variable's sandwiched between your numbers. Or, we always use the word or.
Does the variable have to be on the like same bigger, like greater or less?
Great question. Sometimes you will be solving an inequality and you'll be left with something like this, which looks a little funky. My recommendation, you don't have to, Delta Math will take it either way, I will usually take it either way. But my recommendation for graphing and for finding intervals is to rewrite this in this order. So you're always smallest number to biggest number. It will help you, I promise. So if you start dealing with greater than symbols, try to reorder it.
And I meant like greater or equal.
Oh yeah, it could also have equal signs under there. Doesn't have to, but it could. Any other questions about this notation? Okay. Now, this should be review. A strictly less than or a strictly greater than. If we go way back to Algebra 1, would we use an open or closed circle? Open. Okay, open circle. If we talk about our domain and range, am I using parentheses or brackets? Parentheses. Perfect. Open circle, parentheses. They all go together. Then we add the or equal to, so we add things over here. What changes about my circle? We fill it in, closed circle. What changes? I no longer use parentheses, but I use brackets. Perfect. We're going to add another layer to this on the next page. Okay? But let's do some examples. X is less than, or not less than, X is greater than or equal to -5. We're going to plot this on a number line. You will usually be given a number line. I was not that nice. We have to draw our own, and I'm sorry. But draw a line. Number line. Boom. Okay. Did you make it, Brayden? That's my rule. Okay. Good. Okay, what number has to go on my number line?
-4, 5.
-5. Let's plot it. There's -5. Let me maybe plot a few more for good measure. But again, most of these will be given to you. Hold on. Was it a question? Or okay, yeah, hold on. Okay. Where is one of my endpoints? What number? Where should I put the circle? It's not a trick question. -5. Open or closed?
Close.
Closed. Okay. Let me do this in a different color. Okay. It's greater than -5. Am I going to the right towards infinity or to the left towards negative infinity? To the right. Here's a trick. If your variable is on the left, your arrow matches with your inequality symbol. See how this inequality almost looks like it's pointing to the right? Your arrow's pointing to the right. That's only true if your variable's on the left. Seamus.
Is it fine if I put like the dot in the line like just above?
That's fine. Yeah, if you plot it above, that works. I do it like this because I have colors, but you might not, so that's fine. Questions on that one? Okay, with your shoulder partner, do number 3. Raise your hand when you're done so I can check. If you're already done, then you're probably killing it. Perfect. Is that a 2? Oh yeah, never mind. I thought that was a 3 for a second. I was trying to fact check you, but.
We have a syllabus quiz.
What kind of circle?
Bro, I looked at the Google
open.
Calendar and it says syllabus quiz.
Good. I like your colors tonight.
Are we gonna get our
Ooh, I forgot to mention that.
So,
Real quick, your quizzes. We're gonna take a pause real quick. Your quizzes are in the grade book. If you want to see your score, you can pull out your Chromebook real quick and look at your score. I will not pass them back until everyone has taken it. So probably Thursday, okay? But if you want to pull your Chromebook out real quick and look at your score, you are more than welcome to. Okay. This one, what number for sure needs to go on my number line? 2. Is there going to be an open or a closed circle? Open. And it's less than 2. Am I going towards a negative infinity or towards infinity? Negative infinity. So I draw an arrow. What's that, Braden?
you put the 0 there.
You will get the number line like on Delta Math. It will have it for you. On any test or a quiz, I will give it to you. So yes, if you're drawing it yourself, yes. But if you're not, no. Okay. Okay. Now we can bump it up a level. This is 2 inequalities pushed together and combined with an OR. It's not a simple inequality. What's the other word for it that we just learned? Compound inequality. Okay. We're going to do it the exact same way that we do simple inequalities. What I'm going to do is I'm going to ignore one of them. I'm going to graph this. Then I'm going to ignore the other one. I'm going to graph it. And that's it. And typically, for OR inequalities, your graph will look something like this. You'll have one inequality going towards the left, one inequality going towards the right. For today, this will always be true. For tomorrow, we're going to deal with some special cases, and that might not look like that when we do OR inequalities. But let's do it. Number line. For the first inequality, what number do I for sure need on my number line? Negative 2. Is it going to be an open or a closed circle? Closed. Boom. It's less than or equal to negative 2. Am I going towards negative infinity or infinity? Negative infinity, so arrow to the left. First inequality, done. Let's write an interval for this. If I start all the way over here at negative infinity, are there points over here? Yeah, when do my points stop? Negative 2. Is negative 2 included? Yes, so parentheses or brackets? Brackets, okay. So for the blue inequality, this is my interval. Negative infinity to negative 2. Negative 2 included. Let's handle the next one. Let's make it purple. What number for sure has to go on my number line for this inequality? 1. Here's 1. Open or closed circle? Open, because it's strictly greater than. And it's greater than 1, so am I getting smaller towards negative infinity or bigger towards infinity? Infinity. Arrow to the right. And if you look, we have 2 endpoints with arrows going in opposite directions, just like how I told you it was going to look. The interval for this, what's the smallest possible value I could almost have? 1. Can I have 1? No, so parenthesis or brackets? Parenthesis. And what's the biggest possible value that I could have? Infinity. Okay. Pause. What am I missing? If we go back to last week. Or, and what's the math symbol for or? U, and what's the math word for the big U? Louder. Union. Perfect. Anytime you see or, you put the wide U in there. Union. That's saying this interval or this interval. Okay? Yeah, go ahead. Not included. Great question, because that's a funky looking parenthesis. Not included. Just a parenthesis. Any other questions on this one? Yeah?
Why do we never include infinity? Why do we have it be less than infinity?
If I said check that for me, what would you do? Right? We can't really define infinity. It's not a number that we could plug in and check, so we never include it because it's never part of our solution. A million is, but infinity we can never actually plug in and count it as a solution. Does that answer your question? Ish, without going too abstract. We can't plug it in and we can't include it. It's not a button on the calculator. It's not actually a numerical value. Any other questions? Okay, let's do an and one. Here is in general what your and inequalities look like. I like to think of it as, like a sandwich. We got the toppings or whatever in here, and here's your two pieces of bread. Sandwich and. We do basically the same thing though. I'm going to show you why we graph it the way we do, and then I'll give you the shortcut. Okay? First, if I look just at the left side, what number has to go on my graph? -1. Open or closed? Open. Boom. X is greater than -1. So am I going to the right towards infinity or to the left towards negative infinity? Infinity. Okay. So this, and you'll see why I'm doing this eventually, but this would be this first piece. Then we do the second piece. What number has to be put on my graph for the second piece? 2. Okay, open or closed? Open. Left or right? Left. So this is how I would graph each one separately. But it's and. And if we go back to our Venn diagram, it's where those two colors overlap. So I go back to my graph, and I get rid of anywhere that those colors don't overlap. So I'm just shading this in-between part, making it really, really bold for you. Just the in-between part. But that's why, because this green one has stuff that hangs out over here that we can't include, and this purple one has stuff that hangs out over here that we can't include, so we only shade in between. We sandwich them together for and. Let's look at an interval for this one. What's the smallest possible number?
-1.
Yeah, -1. Oh, parenthesis or bracket? Parenthesis. What's my highest number? 2. Parenthesis or brackets? Parentheses. Do I have anything else on my graph? No. So just -1 to 2, both not included. Questions on that one? Okay. That's how we graph inequalities in one variable. We use a number line. We can also solve inequalities to get them to look something like this so that we can graph it. So sometimes we'll be given something with variables on both sides, and we want to turn it into a nice, simple inequality with a nice solution set. And that's what we call solving inequalities. Works the exact same as solving equations, with one exception, and that exception doesn't matter for this example, so I'm going to talk about it in a second. Let's solve this inequality. If I wanted to solve this equation, if I acted like this was an equal sign, what would I do first? Go ahead.
+4.
+4, okay. And if I add 4, what should I do with my 5x? Subtract my 5x. 2 plus 4 is 6. 7x minus 5x? 2x. Now what would I do if that was an equal sign? Divide by 2, and I would get 3 is greater than or equal to x. I don't like to write it like that. You're about to say it.
Is it only flipped when you multiply it by negative?
Yes, but if I wanted to rewrite this in ascending order, it would be x is less than or equal to 3. This is what I want you to use to graph it. Put your variable on the left. Okay? I promise you, you will confuse yourself if you try to graph it like this. Okay. So that means 3 is an answer, 2 is an answer, 0 is an answer, anything less than 3, or this interval. Remember, for equations, we only had one answer. Now we have an infinite number of answers that we represent as an interval. Here's the difference, though. Didn't matter in this equation. It was going to work out how we wanted it to because I did it the way I wanted to. But if we multiply or divide by a negative, we have to flip the sign. That means if it was opening this way, it's now going to open this way. Okay? You flip the sign. So here, for negative 2x is less than 4, what should I divide by to solve for x? Negative 2. So I divide by negative 2. I flip my sign. So x is greater than negative 2. Same thing for the next one. What should I multiply by to handle the negative and the 4? 4, negative 4. Perfect. So I'm going to multiply both sides. Oh gosh, times negative 4. Times negative 4. Okay, by negative 4. So I flip my sign. I keep my variable where it was. 5 times negative 4 is negative 20. Careful here. Make sure your variable stays on the same side where it was. If you switch sides of your variable, then you need to switch your sign again. So I want to do that all in one step. Do one thing at a time. That's only if we are dividing by a negative. If we are dividing a negative by a positive, we don't flip signs. So here, what would we divide by to solve for x? 2. So my sign stays even though there's still negatives involved. I'm not dividing by a negative. I'm dividing by a positive. So my sign stays. Do we all remember this from Algebra 1, hopefully? Okay. Perfect. Questions on this one? Okay. So we're going to solve them. We can solve simple inequalities. I trust that we can do that. We did one right up here. Now we can also solve compound inequalities. We're not going to graph them. We're just going to solve them. Anytime we solve these, it kind of works different depending on which inequality you have. If you have an and inequality, I want you to look at the middle, figure out what you need to do to it, and whatever you do to the middle, you do to both other sides. Okay? If you have an or inequality, we take them completely separate and we add the or at the end. Okay? So this one we do all together. This one we do separate. So let's do the first one. If I look just at the middle piece, what do I need to add to both sides? 10. So plus 10, plus 10, plus 10. Negative 4 plus 10 is 6. 14 plus 10 is 24. So we get 6 is less than 6x, which is less than or equal to 24. Now I need, go ahead.
Divide by 6.
Divide by 6. I would get 1 is less than x is less than or equal to, not 24, just 4. I could graph this. I could write it as an interval, but I'm done. It's solved. I have the variable by itself, and I have numbers. So we're going to do an activity later where solving all three, like doing all three pieces at the same time doesn't work. And that can happen if we have variables in all three places. So I'll tell you which one it is. But if you do number 19, when we get to our activity, I want you to do it piece by piece. So do the left inequality and then do the right inequality. Number 19 is what I want you to do that on. And yeah, you won't be given any of those on the test. Anything that I give you, you can just do all in one go. But for our practice, I have a pretty hard one, and you'll have to split them up. Okay? Okay. Try number 2 on your own. I want you to follow your or all the way down. I want you to do the left. I want you to do the right. And I want you to stick the ors in between. Okay? So work with the people next to you. See what you got going on. Check with me when you're done.
That turns to 6, right?
You should move that up because I didn't.
Huh.
Yeah.
Is that good?
Yeah.
Okay. Perfect.
That would turn into
Read down.
x.
Yeah. I do that too. Yeah.
Wait, when did you do this?
Right. I usually don't give you every number,
Oh,
so.
no, divide by negative.
Give you what?
So we're fine.
Yeah. Yeah, no, 5 and over, no. Yeah, no.
What is the x minus 1?
Times -4. I put a dot at first and it almost looks like a negative. So times -4 on this side. So. So. Looks good to me. Yes. Yes. Okay, let's do this one. On the left-hand side, what should I subtract over? 5. So I get 3x less than or equal to 11 minus 5 is 6. Don't do it, man. I've heard it so much.
She knows it's corny, bro. Stop it.
Okay. Now what? Divide by 3. And we get x is less than or equal to 2. Okay. Easy peasy. Next one. We should add what number? 7. We get 30 on the right. We divide by 5. We get x is greater than or equal to 6. Okay. This would be your answer if it asked for inequality notation. Or we could do interval notation. So I'm replacing my or with a union. We use ors for inequalities. We use unions for intervals. And then I write my interval. Less than 2. What's my farthest left point if it's less than 2? Negative infinity. And what's my biggest possible point? 2. Included. So we have brackets. Same thing for x is greater than 6. What's my lowest point, my smallest number? 6. Included. And then it's greater than, so infinity. Questions, comments, concerns on any of those? Okay. A few things. We'll do one example, and then we'll be done. Or 2 examples. Okay. We can graph these things as well if they have an x and a y. Crazy enough, we graph them the same way we graph equations with a few extra steps. We might have to make the line dashed or solid depending on our inequality symbols. So we take our equation, we act like there's an equal sign, we graph that line, and we call that line the boundary line. It is the boundary between our set of solutions and the set of non-solutions. And then does anyone remember, well, it says it on here, but these ones, strictly less than or strictly greater than, it was parentheses, it was open circles, and now it's a dashed line. So when you draw your line, you make it dashed instead of solid. Less than or equal to or greater than or equal to was a closed circle, it was brackets, and now it's a solid line. So step 1, you graph your boundary line, you make it dashed or solid according to your symbol. Okay, you sure? Okay. After you graph your boundary line, then we have to shade our graph because we're not just dealing with a few solutions on our line now, we're dealing with an interval of solutions and we have to count for all of those with shading. So I will tell you the way I technically want you to do it and then I will give you a trick. The way I technically want you to do it is I want you to pick a point that's not on the line that you drew. I want you to plug it in. If it works with your inequality, I want you to shade that side of the line. And if it doesn't work, I want you to shade the other side. Typically, the origin 0, 0 is a great point to plug in. I would always plug that point in unless your line goes through that point. Then you have to pick a different one. We're only going to do this step 3 once, and then I will give you a trick. Okay? But I want us to see why we actually need this step. So, let's do it. This first one, going back to hoy vux. Is this hoy or vux?
Boy.
Hoy, so a horizontal line. Should it be solid or dashed? solid because of this symbol right here. Solid. So step 1 is I'm going to draw a solid horizontal line at -3. That's step 1. Then I pick a point, usually the origin if I can. I can in this case because it's not on my line. So I pick the origin and I plug it in and see if it works. This one's kind of weird, but what's the y value of this point? 0. So I'm going to plug in 0 for y. X doesn't go anywhere because I don't have an x. But is 0 less than or equal to -3? Yes or no? No. Does not work. So instead of shading the side of my line with 0, with the origin, I'm going to shade the other half of it. I'm going to shade beneath it. So down here. And that's it. All of these points I can plug in and they'll work. All the points on the line I can plug in and they will work. But anything above that line will not work. Okay, here's the trick. Instead of plugging in points, if you have your line in slope-intercept form and it's y greater than something with x plus a number, you're going to shade above the line that you drew. Makes sense. Y is greater than, so we shade above. If y is less than, we shade below the line that we drew. That will work every time. But we do that because technically we are testing these points and knowing that they don't work. But everything else does. Questions on that shading? Go ahead.
Can you just repeat why we can only it only works below?
Yeah. If we plug in 0, that's a point right here for y. That's any of these points really. We plug 0 in up here. Is 0 less than or equal to -3? No. So that means any of these points are not included in our solution set. Just like if we drew a line, only that line is included. Nothing up here, nothing down here. But now we have this inequality. So we're dealing with more than just the line. We're dealing with the whole range of numbers on one side of it as well. And we determined that side by testing that point. It didn't work for this point. Well, math tells us that every other point on the other side of it has to work. Does that help?
Yeah.
Okay, Seamus.
Can I use a ruler?
Yeah, go ahead. I want you to do this one on your own. Before you graph it, what form should you probably put it in? Slope-intercept. So step 1, put it into slope-intercept. Graph. Make your line dashed if you need to, and then shade. Slope-intercept, graph, shade. When you're done, if you want me to check, raise your hand. Oh, sorry, just like I was snapping at you. Boy, remember horizontal line? Its slope is 0, and you graph it when it's like y. Here we don't have y equals, we have y less than. But to graph inequalities, we just graph the line as if it was an equal sign, and then we do the shade there.
What was the difference option for y or?
Bucks. Bucks is a vertical line. Its slope is undefined. Goes straight up and down. It's not rise over run because there is no run. And that happens when x equals a number. So vertical at the x value. Remember that now? Okay. Any other questions for
We
you?
have to put in Julie. Because I think she just said if it's brighter.
Check your shading.
She says it's
Is
red.
0 less than -2?
No, it's bigger.
It's bigger.
It's not.
Yeah, yours is good. Check with people around you if they're done. I see you all.
Yeah.
All I want you to know is all I want you to know is this. It was y was less than, if we go underneath our line. If it was the other way, if it was y is greater than, we would go above the line.
Okay, and what did we have to change? What was the
The test is technically what you have to do to determine what you need to shade, but this part, we're not gonna do ever again. The shading shows us that there's so many different options for numbers that could work with this equation.
So the shading is what will work?
Shading is what will work. Exactly. Oh, yes, and yours looks great, make sure the line is dashed. Yes, you may.
Shade above. It's like this.
Perfect. Beautiful.
Well, it's like that
Beautiful.
regardless.
Yes.
Oh, okay, we're looking at the negative
Be careful, what do we have to divide by to get to here? -6. So our sign had to flip. Okay, here. When you graph inequalities, I want you to act like this is an equal sign. Graph that line.
Shade above and below. Below.
Perfect.
Because when you divide by negative, you have to flip the sign.
Yeah,
You didn't divide by a
perfect.
negative.
Okay, once you graph the line, you have to determine if it's shaded. The symbol looks like this, or the other like this. That's solid. If it looked like this, yeah. Erase a little bit versus how it
Okay.
Okay, so then you shade. So if it's y is greater than, that's that first part there. Y is greater than the rest of your equation, you shade above. If it's less than, you shade below. Yeah, perfect. And we'll do this one. I was listening to me as I do this next one because it might help you a bit. All right, let's do this one together. I have to solve for y. What should I do first? Sure, subtract 2x. So I would have -6y is greater than 12 minus 2x. Okay, now what?
Divide everything by -6.
And when I divide by -6, Jude, what do I have to do?
You have to flip the sign.
Perfect. Flip my sign. If you don't flip your sign, your shading's going to be messed up. Okay, I'm going to switch my order here. I'm going to do -2 first. -2 divided by -6. Reduced fraction, what is it? 2 over 6?
Yeah.
Reduce it. 1 over 3, 1/3. You don't have to technically if you're just graphing, but you could. 1/3. And then 12 divided by -6. Yeah, -2. So this is the equation we should have gotten. Then we graph it. What point do I know for sure is on this line? 0, -2. Boom. But Braden, what's my slope? 1/3. So I go up 1 over 3. Dashed or solid line? Dashed. That's not a very straight line, but you get the gist. It's y is greater than, so do I shade above or below? Whoa, wait a minute. It's less than. I said I was going to flip my sign, and I didn't. There we go. Y is less than. So is it above or below? Below. Perfect. Questions on that one? One more example, and then we'll do an activity. It says determine whether the ordered pair is a solution. What do you think we should do if I want to determine if this ordered pair is a solution to this inequality? What do we think? Does this work for this inequality? What would you do? Starts with a P. I say it all the time. Plug in, see if it works. So that's all I'm going to do. This is the same as like testing a point. If I wanted to pick a test point, that's all I'm doing here. So 5 times x minus 2 times y. Watch your parentheses here. We're dealing with a double negative. Less than or equal to 6. But really, there's like a question mark here. We're asking ourselves, is it less than or equal to 6? And if it's not, then it's not a solution. 5 times -1, -5. -2 times -7, positive 14. Watch your negatives there. -5 plus 14. 9. Is 9 less than or equal to 6? No. So is this a solution? No, we would say not a solution. I'm not going to go through the rest of those 4 examples. You can do them on your own if you want, but we're going to get into our activity instead. It won't take you that long, I promise. Do we all see the colored paper around the room?
Yeah.
Great. All of those colors mean something. I stole this from the Algebra 1 teachers. It's Algebra 2 content, but I stole the idea from Algebra 1. They call it the hot sauce activity. Yellow is mild. It's worth 1 point. It's your easier questions. Orange is medium. It's worth 2 points. It's your base, like normal questions. Red is spicy. It's your harder questions. You are going to walk around the room, do whatever questions you want, but you have to get to 10 points. So that could be 3 red and a yellow. Red is worth 3. That could be all 5 oranges. That could be 5 yellows, a few oranges, and a red. Up to you. But after you think you have all 10 of your points, come up to me, I'll check it, and then it's your homework time. Okay? Break. Yeah, if you want to use a whiteboard instead of a piece of paper, please. No. There's a whole tub of them back there in that green bucket, and there's markers next to it. Give me 1 second.